Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, let's continue hourly analysis program tutorials. Happy New Year for all of you. This is our tutorial. This is the first tutorial in 2018. Happy New Year. I wish you luck where and whenever you go. I hope you get benefits from learning online by watching these tutorials and any other tutorials. Okay, so God bless you. The previous videos we talked about our analysis program in details, and we covered a lot of information. So in this video we're gonna talk about our analysis program, but using the wizard technique or the wizard option for the quick cooling loads and heating loads and simulations, just for the quick estimation. Okay, so let's make a new project. Entry standard energy lead currency. Okay, general. Okay, so we have here the weather species none. Okay, we have here schedules nothing, the new project. So for the wizards here we have 4 wizards: weather wizard, building wizard, equipment wizard, utility rate wizard. Also we have full wizard session. The full wizard session can be used if you wanna make these things, I think, at the same time. For if you have all the information, you can use 1, 2, 3, 4, and then you can click finish, and you will be able to generate the cooling heating loads report and the energy. Okay, but now we will talk about the weather wizard and the building wizard. The next tutorial we're gonna cover the equipment wizard and utility rate, and then we'll be able to generate the reports. Okay, so for the weather wizard, open it. We have here, those who can click F1. So have here you can choose the city, region, USA, Canada, Central and South America, Europe, Middle East, Africa, Asia, and Pacific. I'm gonna give the Middle East, Egypt, and Cairo. Okay, so here are the location and the city, just quickly. Okay, no need, and here is the instantaneous report. Here the region and latitude and these things. Notice that when we talked about these things in details, we were able to input all these things in details, but now you only can see these things in the report. Okay, you will not be able to enter many details. This is a quick simulation. So close, and here we have the weather Cairo in Egypt in just less than 1 or 2 seconds. After this, okay, so here the weather. The weather wizard consists of input screen like what we have just seen. You can see these things. Please, you can read more. Now for the building wizard. Okay, we have here the general building footprint, the general information, building information, and the building dimensions, and the summary. Okay, for the building type, we have here office, school, healthcare, anything you want. Office building subcategory, low-rise, it is a small building, 1-2 stories, mid-rise 3 to 6 stories, high-rise 7+ 7 stories. Okay, notice that when you choose this, you will be able to change these things. Typical intermediate floor and these things. Okay, so we're gonna make it 3 to 6. Okay, and here is the building identifier. Please, any building here you have to get its an identifier. By default it's BLD1. Okay, then the building shape quickly is rectangular or rectangular with interior courtyard like this, or it is H-shaped. These things is like the eQuest energy simulation software, and I think that I can or I may upload tutorials about eQuest after finishing the aerodynamics program. eQuest is a software that is used uh, particularly for energy simulation, a very powerful tool. If you don't want to use HAP, this is eQuest software. It's a free software. You can download it from the site. Okay, we have here. So I think that I may upload tutorials about eQuest for the energy simulation tool, like exactly like the aerodynamics program after finishing this series. And we're gonna talk about eQuest and Revit for plumbing, the general plumbing. We covered the plumbing for HVAC. We may talk about the plumbing, the general plumbing works, and the firefighting. Okay, so the H shape and L shape and T shape. Notice that the building dimensions, okay, U shape, and these things. Okay, so we make it rectangular, and the zoning method, one zone per floor, it's a block. So this will be considered a one zone or perimeter core. So this is zone 1 and here is zone 2, or by exposure. So here is zone 1, 2, 3, 4, 5. Okay, or by exposure with corners, so you'll be able to make this category. Okay, so if it's H shape and we make it like this, it will be like that, or this. And so you'll find many scenarios you can use like that. Okay, so make it rectangular and make it like this. Here are the zones. For this tutorial we may make it like this, and here is x1 and y1 just to make the dimensions that you need. And here are the also the perimeter, and here notice that this is the north. You can change the north. So here are the building wizard, building type, building and fire, building information, building dimensions. Okay, so you can just change this orientation of the building. It's very important to know where is the north. Okay, so perimeter zone depth. So this is the horizontal distance from the exterior wall to the interior boundary of the perimeter zone. As you change this value, footprint diagram will be scaled to show the relative size of the perimeter zone. Okay, if this 4.6 or 6 meter, notice. Okay, notice that it cannot be 1. There is a minimum allowable limit. 2 meters, no. 3 meters, yes. So here is the list thing, 3 meters. Okay, according to the dimensions, of course. Also the number of floors, you can make it. The number of floors in the building. Inputs may be limited by building subcategory input. For example, if you specify low rise 1 2 stories, number of floors will be limited to 2. you make here, this will be floors 1 or 2. Floor to floor height, the vertical distance between the floors. This value is used to compute the wall surface area, and also floor ceiling height, the vertical distance from floor to ceiling level. The distance is used to compute space volume for converting infiltration air exchanges into airflow quantities. And also here the window area, it's a percentage of the wall, so we have to know this rough by rough. This percentage is very important, the percentage of gross wall area, which is fenestration. Okay, for example, if 15% is specified, the target for each space created is a window to wall ratio of 15%. Note that the actual window to wall ratio in the generated spaces may not exactly equal to the value you define. So using the dimensions of the window assembly specified on the building details input screen, HAP will determine the number of windows that comes closest to the window to wall ratio specified, because HAP will not consider partial windows. The dimensions of your window assembly may result in a window to wall ratio slightly above or below the value specified. Okay, why? Because this is not very accurate calculations. It is based on the quick calculations of this wizard. Okay, of course, the detailed method like what we show in the previous tutorials, exactly you can determine the number of windows and the realistic area. After this, you can get here the summary. You cannot change anything here. You can make it 15. Notice these things will be modified. Okay. So after finishing these things, you can click next to see you have here the wizard screen. Okay, but here the previous, please, we have intermediate. Okay, things. Here is the typical intermediate floor. So what is the intermediate floor? It is intermediate. The building contains 4 or more floors. You can choose whether to represent each intermediate floor separately or with or as one typical floor with a multiplier applied. So if you have the same floor, but you can copy it. If you wish to use the typical floor approach, place a check mark in the box. This feature provides a way to minimize space data created when it is not necessary to model floors above the first floor and below the top of floor separately. Okay. So here next, I'm gonna make it. So I have to make these things. Here for the space usage, you can make or choose what you want. Education, here is the general corridor or whatever you want. Okay, so here the requirement is changed according to the space usage. For the occupancy, you have to get the square meter per person occupancy, exactly like what we showed in the detailed tutorials. Occupancy schedule, you can here use the schedule, or you can add any schedule that have been defined before in the library. Okay, if you have your schedule in the library, you will find it here. So activity level, you can choose the activity level, and the overhead lighting, exactly like what we showed. you have to get the option and light density, and then the overhead schedule. Also, if you have a schedule for the lighting, you can choose it, or you can get the default. Also, electrical equipment to get the power watt per square meter. The heat gain, like I said, the heat gain, and the electrical schedule. Also, you can get the default by here, or you have to define it and then you can select it. Okay, so the building envelope, you can choose the wall type. According to the wall type, you will find here the construction in details. Okay, and of course your value will be changed. The roof type, medium weight roof for 2000 zone, installation above deck, like this. Okay, notice that there are no more many options here. This is just for quick simulations. Also here, the window, you can choose from these defaults. Okay, and here the infiltration, you can put the infiltration. Also here you can choose the user defined if you wanna make it. Okay, exactly like what we have shown. One here, window area, and these things. Ventilation and occupancy. Ventilation members define the outdoor ventilation airflow requirements for spaces in the building. The space usage input allows ventilation requirements to be the default based on the space usage types listed in ASHRAE standard 262, 2001 or 2004 and 2007. The ASHRAE standard currently in effect is shown in the title for this group and inputs. This is changed via the view preferences option in hourly analysis program. Main window items, space usage list match those listed in the selected standard. When a space usage type is selected, outdoor air requirements 1 and 2 are defaulted. If you choose user defined the space usage type, then the outdoor air requirements can be directly specified. Okay, also for these things. Okay, okay, filtration, make it 1, and your SCC. Okay, you can click finish. Here is the report. Okay, general information according to your inputs, and here the north building dimensions summary, and the building details, occupancy, overhead lighting, as exactly what you just input. Okay, so this is the report. You can save it and you can print it. So close. We have here the spaces. Why? Because we have two zones, or I'm sorry, we have here the spaces according to your inputs. Notice, and here is the quick usage. Internal roads, roofs, filtration, floors, and partition. Okay. Notice that here no walls. Why? Because the I think it's all of it partitions. And here we have the main roof walls. Okay, according to the shape. So for this, can print input data, view the input data, as you see in details. and here's the weather. Okay, also you can use these things for the simulation and design, exactly what we have shown. Now suppose that you have here okay, these spaces, and we have here of course we have here the definition by default. You after generating the building or the spaces, you will find these things here. Okay, suppose that we on here the schedule, I'm gonna delete these things, roof and windows. This is automatically generated after finishing the wizard. Both we have here windows, and we define this window, and we go to spaces, no spaces, building, the shape or exposure, next. Okay, here notice, gentlemen, that we'll find here the simple window assembly. So if you don't want to give the default, you can define it in the library project. Also, you can define the schedule, and here are the zones. So here is the window type according to what I've just done. Suppose that notice that we have here 9 spaces, exactly like what we have just done. So schedules also with the things. Yes. Delete of this sample window. Okay, wizard, I'm sorry, cancel. Wanna define a schedule. Okay, sample schedule, wizard, building, and here is schedule. Notice that you can use your schedule, sample schedule, and here also sample schedule. So it's pretty easy to define what you want, and exactly from the library, just for increasing the accuracy. If you need more accuracy, but for quick simulations. Okay, and here we have the zones, zone 1, zone 2. So only you find 2 spaces. The schedules, of course, you wanna see that schedule that RLNS program uses by default 90.1 office lights. You can open it. Fractional hourly profiles. Here are the details. We'll find here the automatic or the default, the design day, and here is the week day. Okay, and here is Saturday, and here is Sunday. Also here are the assignments. Notice that for the design it follows design day and 2 weekday. This is for energy simulations, and Saturday the 3, and Sunday, of course, it is a vacation. Okay, so this is how to get what you want. For the hourly profiles, you have to check all what you want from here. Notice the differences, you can see it. Okay, ladies and gentlemen, I think that I have just finished this short tutorial. Thank you very much. It is pretty easy to use these things. The next tutorial, we're going to talk about definition of equipment, wizard for systems, and the plants, and then the utility rate wizard for energy analysis. Thank you very much. Please save this untitled. Okay, quick building estimation. Okay, save it. Okay, and you can read, of course, more from the F1 help. Thank you very much. Wassalamu alaikum warahmatullahi wabarakatuh.